G'day and welcome back to another gas walkthrough. Today we're looking at the 30th of December 2025's Blame Malrog by Philip Newman. Philip's one of us says here at Gas HQ, Soul Mine. My name is Bill Murphy. G'day, how you doing? This one, well, it's got an interesting story behind it. During the Sudoku Con Twitch stream, Philip was talking nonsense and I jokingly suggested into the chat a $20 donation will let you pick a gas variant, and Philip will say it. Philip's like, you're on. And Malrog suggested this, Killer Lions. So I'm part to blame for this, but mostly blame Malrog. And yeah, a lot of people found this one tricky from what the feedback we got, but no one went, wow, that's really brutal. They just went, it's tricky. Call him Rundin DNC. The N standing for Newman. We are Gas, genuinely approachable Sudoku. We create, set, and solve genuinely approachable Sudoku for you, the person watching this. You'll find the link to today's puzzle in the description down below. You will also find hat times. 2 hats for a very fast time, 1 hat's for a pretty fast time. Everyone gets a dinosaur because we love you all equally. That being said, I'm going to jump into it. Let's do it. So, this is Killer Lions Sudoku. So what does that mean? It means normal Sudoku rules apply. Each box, each row, and each column must contain digits 1 to 9 once each. Now, we have some killer clues. So, killer lines. So, I'm going to read what it says. I'm weirdly going to turn the pen tool on just to, like, help explain it for those who need it. If you don't, great, go crazy. But divide each line into subsections such that each cell on the line belongs to exactly one subsection, and each subsection contains exactly one clue. Each subsection acts as a killer cage. Digits in subsections cannot repeat and must sum to the given total given by the clue contained within. Digits can repeat on a line if allowed by other rules, as long as those digits are in different subsections. Alright, so what does that mean? So I did just turn on pen tool. So basically, what it means is, we're going to look at this line here. So if we were to divide it into subsections, I'd need to oh, that's not gonna. Oh, I thought pen tool would let me draw on the edges. Nah. Okay, never mind. I'm gonna turn pen tool off. So, what it means is this is the start of a killer cage. So, and so is this. Now, what we need to do is divide this line into subsections such that, like, this is pink and this is green. So that way, like, those 2 digits equal 12 and that one could be 6. But the thing that stumbled people a bit is this could also be a valid way of doing it, because the 6 would be a killer cage. And also, even if this was true, 6, 6, 1, 5 would be another way of looking at it. The other example I want to point out before we get into it is I'm going to look at this line here. I could not have this as a killer cage, as a subsection, and like having those 3 cells sum to 17, because this subsection here would not have a clue in it. That's it. That's all you need to know to solve today's puzzle. That being said, I'm going to get into it. So, let's do it. Now, let's start here. So, this is a 1. Because 1 can't be anything else more than 1 digit. Now, down here, this can't be 1, 3, which is one of the ways to make 4. Oh yeah, that's gonna be one of the things I'm gonna do a lot with this puzzle. I'm mostly gonna be talking through possible killer combinations. If you do not have all of them set, don't forget, they're in your brain. Don't forget there is a killer calculator, which is in settings down here, which will let you see what the possible totals are. I've done enough of this that there's only one of these, one sum here where I don't Yeah, there's probably only one sum here that I don't have committed to memory. But it's this one. So, this cannot be 1, 3, because, oh, the killer calculator is not going to work today, sorry, I just realized, because, the way Philip's drawn it in the grid is that's just a 4. So, but that is just a 4, because the only other way you can make, 4 with a killer calculator, killer cage is 1 and 3. So that's 4. These 3 cells are going to sum to 18. Now, what else do we know? Can this just be 1 digit? The answer is no, because if this was 1 digit for 7, these 3 would need to sum to 4. If this was 3 digits for the 7, so it'd have to be 1, 2, 4, which would break because there's a 4 there and a 4 there. So we know it's 2 and 2. This is 1 and 3. This is 2 and 5. Alright, now, cute little bit of logic down here. This 4, what is it? It has to be 4, because the only way you can make it is 1, 3, and now we have 3 cells that need to be just 1 and 3. So, this is a 4. We don't know... Oh, we do know. That's 1 and 5. Because it can't be 2 and 4. We just placed a 4. That's 3 and that's 1. Now, where else am I going to go looking in this grid? I'm going to use that sort of too many cells needing to be that quite a bit today. Let's go... Oh, actually, no, let's go over here. 3. This can't be 3, so it has to be 1 and 2. Bouncing back over here, 5 and 1. This is now 7. Alright. Alright, I think I'm going here now. This has to be 2 cells, cannot be 3, which means this is going to be 8, 9, just immediately. And then, this 5 needs to be 2 cells, has to be 2 and 3. But because I've just placed 1 and 4 down here, that's the only way that can go. Over here, I've got a 2. That's just been sitting there for a while. 16 and 13 means that this is actually forced. 16 needs to be 7 and 9. This needs to be 8 and 5. Alright. Where to now? I still don't know enough to do that. That's good, this is good. I'm gonna just keep noticing stuff all over the grid. Pardon me. This can only be 1, 2, so it must be 3. We're just gonna come back up here and do the 2, 3 for us. We still don't know if that's 1, 3 or just a 4. But we actually know what this is now, which is crazy. Can't be 1, 8 to make 9. Can't be 3, 6 to make 9. This is 5 and that's 5, meaning 5 can't go on one of the 5 has to go on one of those 2 cells. So if it can't be 1, 3, or 4, it must be 2 and 7. This 2, 2, 5 pair is going to unwind that for us. That's pretty decent. We take those. Now, interesting. This one is that... Oh, yeah. 1, 7. Meaning this cannot be 1, 7. It cannot be 2, 6. So this has to be 3 and 5. The 3 here is going to go 3 and 5. Oh, I placed the 7. 9, 7. Now... 5. I love that. Alright, love that for me. Oh, cute. 1, 7, 3 can't go in those 3 cells. So it's 1, 7, 3 have to go here. The only way that that 4 can now be true is if it's 1, 3, 7. This is now 9 and 8. And then 5 must go there, which for some reason I just didn't put in. 4 going up here, 4 and 6. This is 1 and 7. 7, 1, 7. Now, that's pretty good. That's going to tell us something about this 6, because if this 6 is 2 cells, this 1 could never make 12. So this just has to be 6. The 6, where does it go on box 3? Can't go on those 2 cells, so that's a 6. 4 and 8. This, we know what this is. Because if this is 4, 1 and 5, 1 and 4 make 5, we'd need to place a 7 here. Can't work. This has to be 8, 3, 4. Now, trying to see if there's anything easier before I go to the thing I don't want to try and explain. Alright, that's a 2 and a 1. 4 can't be in that cell, so that's a 4, that's a 3. Oh, 8 and 6 going here. That's very good. I feel like I solved this puzzle. I was going as fast as I could. I felt like I may have used some not gas things. I'm glad that I'm finding easier things before I have to explain the normal things. Okay, so over here, this 10. 3 and 8 make 11, so this has to be 6. Now, 6 and 3 make 9, needing the 1. That's a 9. Bounce back over here. 5 and 9. This has to be 7, and it can't be 1, 6, or 3, 4, so it has to be 2 and 5. That 9 I placed is going up here. That's an 8 and a 9. 7 going over here. 4, 6, 8. This is a 9. 6, 7. We can just do. That's nice. And this is 2 and 8, which I can do, because that 2, 5 pair is still not resolved. Going up there, 9 and 8. 3 going there. That's an 8. 6, 7, 9. Now, let's talk about the middle box. 4, 6, 5. That is an 8. Oh, isn't 8. Cool. I've gotten everywhere I can get to without explaining the middle box. So, let's look at... we know that's 6. Why do we know that's 6? Because if it was 9, I'd need to place a 1 there. Can't do that. If that's a 7 there, one of two possible things could happen. If that was a 7, I'd need a 3 there. Make 10. 6 would 7 could also be made with 1 and 2. 1 and 2 we both have. So this is 6, 9, 7, meaning I need to place 4 along here. Can't be 1, 3, so this must be 4. Oh, that's 9, that's 1, that's 4. Take 4 out of there. Can I get away without doing anything harder? Oh, cute. So, here's how we're gonna, so normally we're used to doing 10 in 2 digits, but one of these is gonna have to be 3, because that's how this line is split up. We can tell it's this one. And how can we tell? Where does 7 go in box 5? 7 can't go there, yeah. We already have the 7 for row 5 and row 4. And the 7 up here is going to place the 7 here. Now, can't be a 3 in that cell because we've got that there. So this has to be 1 and 2, making this 6. That is all the variant in this puzzle. It's quite a lot. I really like this one. I think Philip absolutely outdid himself here. 9 and 3, take the 5 out, take the 6 out, take the 6 out there. This is an 8, which is going to unwind our triples. 4, 6, 8. 5, 4, 6, and 5. So, that has been Blame Malrog by Philip Newman. My name is still Bill Murphy. Wherever you are in the world, I hope you have an amazing rest of your day. And I will catch you next time. Cheers.